Hello everyone. In this video I will be going over how series works. So this is the basic formation of series, how it looks. So a series up to n will be the sum for k equals 1 to n of a of k, where a of k is some sequence. And so that will look like a of 1 plus a of 2 plus a of 3 plus all the way up to a of n. And technically you could start from 0, or you could start from like 5, anything you want. But generally people usually start with 1. 0 is the next most likely. Here's an example of a series, so where the sequence is just k. So it would be 1 plus 2 plus 3 all the way up to plus n. So if we want to find, this is a series, and if we want to find what the series is equal to, let's say we want to find the series at n equals 3, it would be 1 plus 2 plus 3, which is 6. But if we want a formula for the general series, where a of k is equal to k, there is actually a formula we can use, which is n times n plus 1 divided by 2. There's also other general rules for formulas that you can use to simplify them. So if there's a constant that's being multiplied by a function, so let's say it was 2k in this case, we can factor that constant out. So if the constant is being summed, we can factor it out, and now it's just being multiplied by the original sum. So again, with this, if this was 2k, this would be 1, 4, 6, but you notice all of these have a common factor of 2. And so we can factor them all out, and we'd get a 2 here, and now this is just the same as 2 times this original thing. There's also, if you have two different sequences being added, or two different functions, because these are really functions, being added inside of the sum, then you can just split it up. Because imagine if we had, one function and another, this is a of k plus b of k. We could just separate out the functions in this form, and then recombine them back here. And finally, if we have a k that's not equal to 1, so let's say we had a k of 5, but let's say we wanted to use something like this formula, which only works from k equals 1, we could split it up into starting from k equals 1 to n, and then subtract from k equals 1 to 1 minus whatever this value is. So let's say we want this formula, this sum, but we wanted to start from 4. So we would look at the whole thing, including the 1, 2, and 3, and add it all up to whichever n value we wanted. And then we would subtract the sum of 1 plus 2 plus 3. So we could just subtract the smaller sum to get this sum that's been moved up a certain amount of k. Here are just some general formulas for different sequences or functions you could have that's being summed. So if it's just a constant, it will just be that constant times the number of times you were adding it together. And then if this was 0, then it would be c times n plus 1 instead. Then here, this is what we saw before, and if k is 0 here, because if k is 0, this is 0, then this actually doesn't change. And here, k squared, you'll get this more complicated formula. K cubed, even more complicated. Generally, you can keep on having higher and higher powers here, and there is a formula for that. And you know that the formula is going to have, like, the degree of this final thing is always going to be 1 more than the degree of here. As you go higher, it's, k to the 4th, you're not really going to be using cortex that much. But here, let's go through an example of if we solve a complicated polynomial inside the summation. So how would we simplify it and get it to an easier formula to find? So first, we would split it up using the rule we saw on the previous slide, because these are being summed, so we can just split it up into these 3 different sums. But these are still equal. And then we can use our knowledge of these formulas. And this would be k squared. This is 3 times the sum of k. And this is 4 times n. And then we just combine it all. And if we want, we can put it back into the form similar to here. Then this would be the answer. And all of these are exactly equal. And I should say that n is always has to be a whole number or an integer, and same with k. Usually they have to be positive, or k can start with 0, but generally they will be positive integers. If you have a fractional value, the way you would do it is you would go up to and not exceed it. So if you had like 2.5, you would stop at 2 and not go to 3. Now we've done polynomials, but what about kind of a geometric sequence that we're going to take the series of? So a geometric series. So for example, we could have, if it's 2 to the n, 1 plus 2 plus 4 plus 8, and then we plus 16, on and on and on, until you got to 2 to the n. But how would we find the formula of that? Well, if you know binary well, you know that if you just add one more and you have a 1 in every place, you'll get to the next digit. So we're 1 away from the next power of 2. But now let's see if that works for other values. So if we have 3 to the n, if we have, let's say we want to find, the next one would be 81. These do not add up to 80. So what could we do? But what they do add up to is 40, which is half of 80. And so this is actually the formula that you can use for 3. Generally, let's think about, what if we wanted 10 to the n? 1 plus 10 plus 100 plus 1,000. We're going to get like 1,111. But we want to relate it to the next power of 10. How would we do that? We would multiply it by 9 and then add 1. And here, with 3, we multiply by 2 and then add 1. Here with 2, we multiply by 1 and then added 1. So we always multiply by 1 minus the base and then add 1. But then when we want to actually find the formula, it will be kind of the next value of n, minus 1, and then divided by the base minus 1. So this would be this formula. And this formula actually works for every single value of b except for 0 and 1. For 0, it doesn't work because at k equals 0, we would get 0 to the 0, which is an undefined expression. And then for 1, we would get 1 minus 1, which is also undefined with 0 in the denominator. But for every value, for 2, 3, 4, 5, 6, 7, 8, for 0.5, for pi, for e, for negative 17, for any real number, and in fact, any complex number too. So like 5 plus 7i, that still works. Any complex number except for 0 and 1 is true for this expression. And then even these are technically true if we take the limit. So the limit as b goes to 0, this is still true. And the limit as b goes to 1, this is still true. But explicitly, we can't use these because they're technically undefined. All right, and that is series. Thank you for watching. Leave any comments if you have any questions, and I will see you in the next video.